let's look at a more realistic example of what we would use the stack for. In fact, we will use the stack constantly for what I'm about to show you. I have do it proc here. This is where we come in, and let's say we want to take all the registers, the values in the registers, and we want to multiply them together for whatever reason. Doesn't really matter. I'm going to move into EAX the value 1. Move into EBX the value 2. This should look something very similar from a few videos back. Move into EDX a 4. So I'm just picking these numbers at random, even though they're not really that random. But I want to multiply all the values in all the registers. So 1, 2, 3, 4. I'm using my Alt key there to do that highlight trick there. I hold down Alt to do that drag. Okay, and then I want to call multiply all of the register values together. That procedure name is way too long, but why not? I'm going to do it anyway, and then we'll do our end proc right there. And the first thing I'm going to do is do return here, because if we don't do return, then when we call into this, well, you've seen we can run off the end of our function, and that's really bad. Okay, so here's do it proc. Calling into multiply all the register values. When I get right here, meaning we have returned from this subprocedure, I expect the values of E, B, C, and DX to all be exactly what they were before I called the procedure. All right, and I'm actually going to lengthen this procedure name. I'm going to say into temp. We need to multiply all the values into temp, and you may ask, Jamie, what is temp? Well, it's right here. It's a temp D word, 4 bytes, and we'll start it out at 0. So when we get back to right here, I expect temp to have the result of 1 times 2 times 3 times 4. What is that? 2 times 3 is 6 times 4, 24. And so right here, I would expect temp to have that value in this case. I could change this all I want, but I expect temp in this case to have 24, and then A, B, C, and DX registers should maintain their values of 1, 2, 3, and 4. This procedure should not screw that up. All right, so let's go down into this procedure and actually write the code. Well, you may think, James, this is going to be easy. Let's multiply EAX by EBX, and then ECX, and then EDX. But if you remember, the multiply instruction messes with EAX. Okay, remember it stores the result always in EAX, and then it also stores the result in EDX, the upper 32 bits. We've seen that in previous videos. Remember when we do a multiply, then the result is stored in the EDX, EAX pair. Thus we get a 64-bit result and not just a 32-bit result. Well, just by using the multiply instruction, we are going to mess up the EAX register and the EDX register. So right here we've already violated an implicit contract between this procedure and the procedure that's calling it, and that we are going to lose the value of this 1 and we're going to lose the value of this 4. That is not nice. Okay, we need to save away any registers we are going to use. We need to save their state. And then right before we return, we need to restore that state. So it's actually quite simple. Watch what I'm going to do. I know I'm going to mess up EAX, so I'm going to copy EAX onto the stack. And I'm going to copy EDX onto the stack. And then right here, I need to pop them in the reverse order in which I pushed them. So pop EDX, pop the top of the stack into EDX first, then pop the next value in the stack into EAX. So hopefully what you're seeing here in this case is that we have a 1 in EAX, so we're going to push that 1 there. And then we have a 1 in EDX, or not a 1, a 4, and we'll save that value there. And then when we get down here, we'll say, hey, now that I've messed up EDX and EAX, pop this 4 back into EDX and pop this 1 back into EAX. So hopefully you're seeing that. That's a typical pattern. When we write procedures, it's up to the procedures to save away the registers they're about to mess up and restore that state later. Why is it up to the procedure to save the registers? Why doesn't the caller save the registers? Well, right now we know that multiply all the register values together into temp is only going to mess up EAX and EDX. But up here, we don't really know that. It's not, well, I guess we could look down here and check it out, but we really shouldn't have to know that up here. All right? But if it's up to us to save away that state, then we would have to push EAX and EBX and ECX and EDX. We'd have to push all those registers, which is a waste. Right? This procedure is not going to mess up ECX nor EBX, so we don't want to waste all that time pushing register values that we don't need to. So thus, we leave it up to the actual procedure to keep track of and maintain the registers that it messes up. And now that all that is left is actually write the code to actually do the multiply. So it should be pretty straightforward now that we've saved off EAX and EDX. Let's just simply, all we need to do is concatenate these values in the EAX. So we already have the 1 there and kind of meaningless, but multiply EBX, multiply ECX. Now we could say multiply EDX, but once we do this first multiply, that's going to eliminate the value that was in EDX right here. And yes, we've saved it on the top of the stack, so we could prematurely just say, hey, pop EDX, then we would no longer need to do this pop, but once we do this multiply, that vaporizes EDX as well. So I'm actually going to push EDX twice, one time to maintain the value for when we do this multiply, and then another time when we actually want to restore the register state. But before we actually pop into EAX, I notice we need to move our results into temp, because that's what the name of our function is, multiply all registers values together into temp. So now that we have the value in EAX, we need to move it into temp, and then sure enough, restore EDX, restore EAX, and I think we're done. So we call the procedure from here, and then this procedure is called from C++. We've seen that before, and we need to return from that, which, remember, that just pops the top value off the stack into the instruction pointer. We've seen videos on that. Let's see if this actually works, and hopefully it does. Control-Alt-D, and get rid of that. F11. And what's that hanging out over there? Okay, so EAX, EBX, and we could put any values here we want to. It's just I'm working with simple values here. So EAX through EDX, I'll take on the values 1, 2, 3, 4, like so. And then we call into our procedure here. So F11, scroll back here, and now we're going to save EAX and EDX. Let's go look at our stack first. I'm going to copy the stack pointer here, 0x, Control-V. Enter, and we'll scroll up. Oops, scroll up slowly because the stack grows upwards visually, but downwards as far as the addresses go. This is our original stack pointer, and so anything we push beyond here, all of this will belong to us as we deem we want to use it. Unfortunately, we're only going to need to push 3 times. So save away EAX, there's a 1. Save away EDX, EDX is a 4. So now those are saved away. Let's save away EDX one more time. Remember, we needed to do that for the multiply of EDX right here. Multiply EAX, EBX, so we're going to accumulate, notice the A, that stands for accumulate, so it seems appropriate to accumulate the multiplication result of all of these registers into EAX. So it's pretty straightforward. Multiply EAX by EBX, that's a 2, and then next is ECX against EAX, that'll give us a 6. And then notice the EDX register, that's the upper 32 bits of the entire 64-bit result, and that went to 0 because we didn't have any overflow. So now we will restore the state of our register, which it originally was right here. Let me do a different color. All right, here is our stack pointer right now, A50, A50 right there. So here we go, F11, and notice EDX, we've restored the value. Now we can multiply EAX against EDX. So 6 times 4 will be 24, or a 1/8 in hex, that's 16 plus 8. Notice EDX went back to a 0 because we just did a multiply instruction, and we didn't have any overflow. And now we're going to move the result into temp, which is at this address right here. So move that. We've saved it away. I don't have that piece of memory shown on the screen. And now we're going to pop EDX, the stack pointer. When we did that pop originally, our stack pointer is now here. Here's EDX's old value. Remember, this was a 4, and this was a 1. We've already copied the 18 out to a different part of memory, so we're okay there. Let's pop both of these values. EDX will be a 4. EAX will go back to a 1. We've restored all the state that we've messed with as far as the registers go, and this multiply all the registers value into temp. Procedure, let's return. Okay, and then right here, if we wanted to, we could look at temp, and temp has the actual values. So we're good. Anyway, that's typical when you call into procedures. Procedures need to be responsible to save away the current state of any registers that they're going to modify. We could have the caller save that state away, but then that would be a waste because generally the caller would have to save away all the registers, and the procedure might only use 1 or 2 registers or none of the registers, and so that would be a waste. So thus we leave it up to the actual procedure by convention to clean up after itself.